Hello friends, today we are going to see photoelectric effect and Lenard's method in modern physics. Myself Dr. Yogesh Balwantara Sal, working as Associate Professor in Gandhi College, Gada. Photoelectric effect is related to the electromagnetic radiation. The photoelectric effect is the emission of electron when electromagnetic radiation such as light strikes a material. In brief, we can see that when the electromagnetic light is incident on a metal, then ejection of electron starts. That process is called as photoelectric emission, and the ejected electrons are called as photoelectrons. This effect is called as photoelectric effect. There are different laws of photoelectric emission or photoelectric effect. See these four laws. The velocity of electrons emitted is independent of the intensity of incident light, and it depends only upon the frequency of the incident light. Whatever incident light is going to produce a photoelectron, the velocity of the ejected photoelectrons are independent of intensity, but it depends on frequency. That means if frequency is large, then velocity of electrons is also large. Then what is the second? Photoelectric current, that is the number of photoelectrons ejected per second, is proportional to the intensity of incident light. That means what? If the intensity of the incident light is large, then photoelectrons whatever ejected, that are also large in numbers. Number third is of threshold frequency. See, when the electromagnetic light is incident on the metal surface, then directly electrons does not emit. Initially it may happen that electrons does not emit. Then if we increase the frequency, and it is observed that whether the electrons are ejected or not. Again, if we increase the frequency, at a specific frequency the electron ejection starts. That frequency is called as threshold frequency. It is called as minimum frequency at which the electron ejection starts from the metal surface. That minimum frequency is called as threshold frequency. Below that minimum frequency or below the threshold frequency, no electrons are ejected from the metal surface. Electron ejection starts from threshold frequency. As frequency increases, these electrons are also increases. The velocity of electrons are also increases as the frequency increases. Number fourth law of photoelectric emission is that this is an instantaneous process. What does it mean? When above threshold frequency light is incident on a metal surface, then electron ejection start. This is a continuous process. Whenever above threshold frequency light is incident, electron ejection start. This is called as instantaneous process, and there is no time lag between the light incident and electron ejection. It is very less time lag between the light incident and electron ejection. This process has no time lagging. As above threshold light incident on a metal surface, electron ejection immediately produces. Okay, these are the four laws of the photoelectric emission. Then we will move towards the next topic. Today we will study Lenard's method. This Lenard's method consists of introduction, working, graphical working, and mathematical extent to determine E by M ratio, where E is charge on electron and M is the mass of the electron. So Lenard's method is
used to define or to determine E by M ratio, electron charge per mass ratio, and this is divided into 4 sessions, that is introduction, working, graphical working, and mathematical expression. So this is the our Lenard's method. So Lenard's method, we will see first principle. This Lenard's method is based on the principle photoelectric emission. This photoelectric emission we have already knows. When UV light is incident on a metal surface which is kept at a negative terminal, then electrons are ejected if the incident light having a frequency above threshold frequency. Then and then electrons are ejected through the cathode terminal. So this Lenard's method is based on the same principle. Now we will see construction. So this, whatever you observe in the screen, that screen is nothing but a glass chamber. This is made up of a glass. Suppose the border white light is made up of a glass, and this is evacuated glass. That means what? Total air through that glass chamber is evacuated. No air particle present inside the glass. So the UV light is passed through that glass material. So outside border, whatever you observed on the screen, that is consisted inside the glass chamber. So this is very important. Only the electrometer, these two E1 and E2 are outside part. Only E1 and E2, these two are outside part. Others are inside. So this, in construction we know that in the left side it is observed that there is a C, that is cathode terminal. Cathode is made up of metal. This is connected to the negative terminal of the battery, or some negative voltage is given to cathode. Then ahead to that there is one anode. Anode is there. We observed that anode, that A plate is there, and A plate, this A plate is actually, this is the total line. This A plate is continuous. So this A is like a slit, it observed like a slit. So only a small pinhole like a space is over there, and this, only through this the ejected electron can pass. Okay, so this is A. This is made up of a metal plate. So this is made up of a metal. Again, only pinhole like a space is empty, so that the ejected electron pass ahead. So there are again P1 and P2. These two plates are there. These are again anode plates, or having a positive potential. These two plates are placed. One is horizontal to cathode terminal and another is parallel to cathode terminal. C1 is parallel, P1 is parallel to C, and P2 is kept at a horizontal to cathode metal plate. Then after some time, magnetic field is to be applied to the figure. So to the setup, and E1 and E2 are what? Electrometer. These are two electrometers are placed. These electrometers are grounded. These two electrometers are used to measure the number of electrons produced by cathode terminal. So this E1 and E2 measures what? The number of electrons produced by cathode. So this, through this glass the light is passed. This is total evacuated. No air particle is present inside the glass chamber. Only light can pass. So this is about the construction of the Lenard's method. Now working, how it works. So see, when the electromagnetic light or UV light is passed through UV crystal, quartz crystal, there is some crystal light filtering arrangement is kept over there, so that UV light is incident on that quartz crystal, the light gets filtered, and the filtered UV light is produced or incident on a cathode terminal. So we know that now if the incident light have a frequency above threshold frequency, then and then only electrons are ejected from cathode. If the incident light have a frequency below threshold frequency, no electrons were ejected from cathode terminal. So we have to keep in mind that the incident light have a frequency threshold above threshold frequency. Above that frequency, electrons are ejected from cathode terminal. So once UV light is filtered light incident on a cathode having higher than threshold frequency, then electron ejection starts. Okay, so A is what? Our filter now. Only small pinhole like space is there, and through that space only the electrons pass. Whatever other electron which are incident on a metal filter, that are absorbed and kept over there only. Only that electron pass ahead to P1 terminal, which electron are incident on that hole only. So this electron passes through hole, that minus sign you observed on this figure, in the figure, and the electrons are passes through that space only, not from other space electron pass ahead. So only the path of the electron that is on the dotted line, and initially no magnetic field is applied. Okay, that ejected electron directly incident on a plate P1, and the number of electrons are counted by electrometer E1. Okay, whatever electrons are incident on a plate P1, that are directly counted by electrometer E1. Now we have to apply what? We have to apply magnetic field perpendicular to the experiment, perpendicular to the experimental setup, or perpendicular to the anode terminal. Okay, so magnetic field we have to apply, and we are going to apply magnetic field in the perpendicular direction. That is what? If the flow is towards P1, then we are going to apply on the vertical direction, perpendicular direction we are going to apply in both sides. So now we are applying magnetic field for the track of that electron near anode terminal. Now what happens? As the electrons are ejected from the cathode terminal, we have applied what? Magnetic field. The very small amount of electron pass directly and hit the P1 terminal, and these electrons are counted by P1. Very less number, because we have applied magnetic field. There is obstacle to the electrons at anode terminal. So now the electron change their trajectory path. The electron changes their trajectory path and moves on the green circle border. Now the electrons moves from A terminal and incident take a curvature path and incident on a P2 plate. Whatever electrons are take a curvature path and incident on a plate P2, the electrons are counted by electrometer E2. The electrons are counted by electrometer E2, and these electrons are, we observe that these are in a higher number. So what we observed, when the electrons are incident on a cathode, initially no magnetic field is applied. The electron directly passes on filtered through anode, and directly pass towards the plate P1. These are counted. These are in high number. But magnetic field is applied, then what happens? The electrons take a curvature path, and these electrons are incident on a plate P2. These electrons are counted by electrometer E2. So the electrons take a curvature path. Okay, electrons takes curvature path. Now how we define it mathematically? Initially we observed, we have applied the voltage to the cathode terminal. So whatever electrons, V amount of voltage is applied to cathode terminal, so the energy is EV. That electrons again rushes towards the plate P1. It has energy half mv square. So this V is what? Potential or voltage applied to the cathode terminal, and this is equated to what? Kinetic energy of the electron which are ejected from cathode and directly incident on a electrometer E1. So one energy, that is EV, V is voltage, E is electron charge, is equated to what? Another energy, that is half mv square, where m is the mass of electron and v is velocity. Here two v's are there. So this is first v and this is second v. Now after magnetic field, what happens? Once we apply magnetic field, then the energy becomes BeV, because B is what? Applied magnetic field, and this energy is counted as a BeV, and it is equated to what? The electron takes a curvature path. So this curvature path, if we joined continuously, then we get a circle. We get this type of circle. So this circle have a radius, and if once electron moves on a circular path, it possesses centripetal force, and the centripetal force is given by equation mv square by r, where r is the radius of that electron which are moving on trajectory path or circular path. If we solve this, we get observed. Now left side is a v, BeV. Now in first equation, another equation, BeV is equal to mv square by r, and here the VV get cancelled, BE is equated to mv by r, and we get from this velocity is equal to BER divided by m. If we square both sides, we get v square is equal to b square, e square, r square by m square. If we put this v square value in equation 1, we observe that EV is equal to half m, this squared velocity value, b square, e square, r square by m square. So this 2v, e get cancelled, we get 2v is equal to half 1 by m, b square, e r square. So if we solve this for e by m, so e by m is equal to 2v, e by m is equal to what? 2v divided by b square r square. So this is the formula we observed. Now what? E by m depends on what? Applied voltage, applied magnetic field, and radius of the curvature path that electron produced. So E by m, that is charge on electron divided by mass, depends on velocity, voltage applied to the cathode terminal. B is what? Applied magnetic field, and R is what? The radius of the